looking today at 4.5. We're going to be talking about mid-segment. We looked over the past couple days. On Monday, we took our notes. Yesterday, you had a work day on special segments, altitude, median, angle bisector, and perpendicular bisector. So this is also a special segment. It falls into the same category as those, but we're going to go a little more in depth with this one. That's why it's getting its own day, its own set of notes. So let's start with what a midsegment is first. Okay, so a midsegment is a line segment that connects to midpoint. Okay, so in this image over here, you can see we've got midpoints marked at D, E, and F. So these dashed lines that connect midpoints to each other, those are midsegment. The most common mix-up of the special segments that, just from my experience, I think is people mixing up medians and mid-segments. So just remember, mid-segments connect midpoint, okay? A median connects a midpoint to a vertex. That's the difference. So if I took this mid-segment E and connected it to B, the vertex, that's a median, okay? Or F to A or D to C. So a median connects a midpoint to a vertex. A mid-segment connects multiple midpoints, two midpoints, okay? Now, for every triangle, you will have 3 midpoints, and you can see that in our graphic here to the left, all 3 are drawn, okay? Because if you connect all of the midpoints to each other, it's 3 different segments. Okay, when all 3 of those are drawn, this original triangle ABC is split into 4 congruent triangles. Okay, and we'll talk about how those are all congruent here in a minute with our theorem. So the triangle midsegment theorem says that a midsegment of a triangle is parallel to the side of the triangle, and its length is half the length of that side. Okay, so I'm going to do some color coding here, some highlighting. So in this example here, next to the theorem, we only have one midsegment drawn, DE. So DE is going to be parallel to a side of the triangle. Now, I think it's pretty obvious it can't be parallel to one of the sides that it intersects, can it? Okay, parallel means it's never going to intersect. So it's parallel to the third side, the side that it doesn't intersect. Okay, so AC is parallel to DE. Okay, and then the lengths of the midsegment and that side that it's parallel to have a special relationship. So I'm going to put the parallel markings on here. Okay, so those are the parallel sides. Now it says here that the segment, the mid-segment, is half that third side. So you can set up, when we're solving for missing parts, you'll be able to set it up this way. If you know the third side, you would just take half of it, and that would get you your mid-segment. But you can also go in reverse. What if you know the mid-segment and you want to know the side? So if I knew this mid-segment was 2, how long would this side be? 4. So instead of taking half, you double when you go backward. So you could also write this out as AC is twice DE. Okay, so just know that you can go in both directions with the mid-segment theorem. Okay, it can help you go in both directions, from a side length to a mid-segment length, or a mid-segment to a side. So far, so good? Now, let's go back to this image up here in the top left corner, now that we know that that's the relationship between these sides, okay, let's look when all three are drawn out. So if I look here, let's start with EF. So if I'm looking at segment EF, okay, what is it going to be half the length of? AB, okay? I'm going to highlight on here, but then erase. So don't highlight this stuff. I'm just using it to point something out, and then I'm going to get rid of it. So those are the two that are parallel for EF, right? So since that is already showing that D is the midpoint, because it's got one tick mark on AD and DB, it's showing that D is cutting AB in half. Do y'all agree? And they put one tick mark on each half. Well, if EF is half of AB, couldn't it also get one tick mark? Yeah. Okay, so you can add that tick mark. Okay, now I'm going to move my highlighting. We're going to focus on another side. Okay, so now let's look at, nope, that was not supposed to be an eraser. That was supposed to be a highlighter. Look at AC to DF. So if we look at that mid-segment and side length relationship, same concept, right? DF is half of AC. And since E is cutting AC in half and they have it marked with 3 tick marks, I can put 3 tick marks here. Y'all agree? And I'm going to do the same thing. And I'm going to focus on that last mid-segment. DE is going to be parallel to BC, which means it's half its length. And since F is cutting BC in half, and they've got each half marked with 2 tick marks, I could put 2 tick marks here. All right, so do y'all see how I added the 1, 2, and 3 tick marks to these mid segments? Do y'all see now how there's 4 triangles that are created here? And you'll notice, maybe you do, maybe you don't, but some of you may notice that these 3 triangles that connect to one of the vertices, one of the corners of the original triangles, they're all drawn in the same direction, aren't they? Yes. Okay, you've got the 3 tick marks on the bottom side, the 1 on the left, and the 2 on the right. But that one in the middle, that one that's created by the mid segments alone, it's rotated around. Do y'all see that? It is still congruent. It's just in a different direction. Is everybody okay with that? Okay. So we're going to use this information we've learned about mid-segments and try and answer some of these examples now. Okay, so in this one down here, before I even start, I like to add markings to my image. So I've got all 3 mid-segments drawn, okay? I'm going to add my tick marks. So this is going to have the 1, this will have 2, and this will have 3. Y'all agree? Okay, so now I know which sides are equal. So let me focus on that first. It says to find BD. Well, BD is this mid-segment that I put 3 tick marks on. Okay, well, down here, there's 3 tick marks for AF and 3 tick marks for FE. They have the grand total of AE is 17. So what am I going to do with that to find BD? I'm just going to cut it in half. I'm going to divide by 2. You can leave it as a fraction, or you can write it as a decimal. Okay, but that's going to be the length of BD. Right now, I'm going to skip the angle for now. I'm going to come back to it. I'm going to look at just side lengths right now. Now they ask, how does BD compare to AE? How would you describe BD compared to AE? Jean, close your laptop, please. If y'all have laptops open, they need to be closed. How does BD compare to AE, Owen?
BD is equal to 1/2 AE.
Okay, so I could write it as in words. I could write that out, or I could write it as an expression, and I could say BD, without erasing maybe, is 1/2 of AE. Good. Or I could write that in words. Ian, is that the same thing you were going to say? Or you... Okay, there's one more thing we could say about them. What else could we say, Ian?
AE equals 2 BD.
So I could write that backward. Good. I could say AE is twice BD. I don't know why that's trying to open. That's not what I was going for when I said one more thing, because that's really just the reverse of this. That's the same relationship. Besides the side length, what else could you tell about those two? What did we say up here? They're parallel. Okay, you need to know that they're parallel because that's what we're going to use to find missing angle measures, are parallel lines and transversal relationships. Okay, so we can also say that BD is parallel to AE. Okay, and again, you can write all that in words. I wrote it in expressions like geometric language. You can write it in English if you prefer. What do we know about BF and CE? So BF here and CE is here. So what do we know about BF and CE? So what could I say? Good. So this one I wrote in words instead of an equation. What else could I say? Okay, so again, you can write it in words, you can write it in expressions. What does, okay, now this last one's angles as well. Okay, so now let's go back to look at angles. So we've talked about side lengths and mid segments and how they compare. Let's talk about the angles. Okay, so we said that it creates these, all three mid segments drawn create 4 congruent triangles, and that the middle one is not written or drawn in the same direction as the outer 3, correct? Okay, but what I know about parallel lines and transversals, okay, again, I wouldn't highlight this because I'm going to move some highlighting, but let's start here because this is where I've got the 26-degree angle drawn. I've got parallel lines and this transversal. Do y'all see that relationship? Just focus on the parallel lines, the green ones, and this transversal. So what other angle here would be 26 if this one is? In what I've highlighted, in what I'm focusing on right now. Look, DFE, okay? So I'm going to label that. That's this angle here. Oops, I don't want that red. I'll just do it in black. Actually, I'll do blue. So this angle here is congruent to 26 because they are alternate interior angles. Do you agree? Okay, so now if I take that highlighting away and I focus on a different set of parallel lines and transversals. Ooh, not what I wanted to take away. Let's look at these parallel lines with the transversal here. So do y'all see that one? What would be 26 degrees in this highlighted blue image? CBD. Here. Because do you see how those two, when we're looking at these parallel lines, these are the alternate interior? Okay. And then last but not least, let's look at these parallel lines. And actually, for the 26-degree angle, the one that's marked doesn't touch those, so I'm actually not going to do that one. But I do want you to notice this triangle over here is the only one we don't have one of the marked 26-degree angles. But notice how it would be a corresponding angle if we looked at, let's highlight these again. These two parallel with this is the transversal. Do you see how this angle here corresponds to this angle here? Okay, so those would be corresponding, so I know they're congruent. Okay, so because of all of those different angle relationships with parallel lines that we learned about, we're able to see all of these that I marked in blue with an arc, all of those are the same. They're all 26 degrees. Now, here's where I think the tick marks come in super handy, because notice how the one given to us as 26 is where the 1 tick mark and 3 tick mark sides meet in this middle triangle, right? Y'all see that? Notice it's also where the 1 and 3 tick mark sides meet in all of these others, isn't it? So you can kind of use the tick marks to help you find the matching congruent angles if that's easier for you than looking at all the parallel lines and transversals. Okay, so that means that every angle that's between the 1 and 2 tick marks is going to be congruent to each other in each of these triangles. And the ones between the 2 and 3 tick marked side are going to be congruent to each other in all of these triangles. Do y'all follow? Now, this particular problem only asked about CBD. So now this highlighting I am going to leave. CBD would be one here, which we already said was congruent. So that is 26. And then the other angle that it asked about down here, it asked about CBD. How does it compare to BDF? Where BDF was the original mark 26. And we already said that they are congruent. Okay, the reason they are congruent, we said they are alternate interior angles. You feel okay about that? Okay, let's look then on the back. Okay, so this first section up here is asking you to find the missing variables, and it is not marked in the picture that any of these are mid-segments. There's no tick marks telling us that these are midpoints, but they tell you in the instructions. They say, assume that all the line segments within the triangle are mid-segments. Okay, so we're following the instructions and that we're being told that these are mid-segments. And we said that a mid-segment compares to the parallel side, which these would be the parallel side, right? How? What's the relationship in their length? The mid-segment is half the side, right? So what's X going to be? Okay. That one's pretty straightforward. Okay, the side is double the midsegment, or the midsegment is half the side, however you want to think of it. Now, 6 is not as simple because we've got an expression and not just an integer value, but we can still set it up. We can say, okay, what should that side come out to be? This should be 14, this side. So I'm going to set those equal. I'm going to say, okay, 2x plus 3 should be 14, and then I'm going to solve. You feel okay about that one? All right, what about 7? If I know the side length is 58, what must the midsegment be? So if I know that this is 29, I can set 5x minus 1 equal to 29 and solve for x. All right, now 8 gets a little more complex. They have 2 midsegments drawn. So let me try and color code here. So the x midsegment is parallel to the 28. So what should x be? That's half of the side length it's parallel to. Okay, now the 15 midsegment is parallel to the y plus 6. So what do we know that that side length over here should be? It should be 30. So we're going to set y plus 6 equal to 30. I know a lot of you would do this in your head as well. You would just say, I can do that, and that's fine. But for the sake of our notes, I'm writing it out so you know where 24 came from. Okay. So another one with multiple midsegments drawn. So I'm going to color code again. So the x midsegment is parallel to the 5x plus 18. Now this one, I don't know either side length. Over here, I knew at least one of them, so it was easier to set up. Here, I don't know either, so I have to write my expression like I did, I told you you could do here, either as the midsegment is half the side, or the side is double the midsegment. I prefer to double things rather than half things, because I think multiplying is easier than dividing for most people. So I'm going to write this out as the side length is twice the midsegment, which is just x. But does everybody understand how I set that up? I did the side is double the midsegment. I just plugged those in. Okay, now that's just a 2x. I don't really need the parentheses in this one, but when you're setting it up, if the expression was more than just x, you would need parentheses because you'd have to distribute the 2. Is everybody on the same page? So here then I would subtract the 5x to get the x's together. Divide out the coefficient of -3. And I would get positive 6. Okay, now for the other, this z plus 8 is my midsegment. Oh, and I didn't put the same number of arrows in blue. I think that one erased, maybe. There we go. Okay, so this one is parallel to this side. So again, I'm going to do that same setup, but this time it's not just z, it's z plus 8. So the parentheses are going to matter. So I'm going to have 3z minus 10. So the side length is twice the midsegment, and the midsegment is z plus 8. So now I have to distribute that too. So I've got 3z minus 10 equal to 2z plus 16. I'm going to subtract the 2z to get z's on the left. I'm going to add the 10 to get constants on the right. That's going to give me z is 26. Now, all of these, when you solve for a variable, how could you check all of these? Plug them back in. You can always plug your values back in when you're finding variables. Okay, solving for a variable. Plug it back in and make sure the mid-segment comes out half the side length. So far, so good? All right, last one down here. We have this graphic, and we're told that QR and PQ are mid-segments. So I'm going to go ahead and draw some tick marks on them. So PQ corresponds, or is parallel to, I should say, GJ. So it's going to have 3 tick marks. So that means that this will be 19 and this will be 19. Do y'all agree? Yeah. Okay, and then QR is going to be half of HG, so it's going to have the 1 tick mark. Now, if 27 is that total length, what are we going to do to get half? Yeah, just divide by 2. So what are all of these that have 1 tick mark going to come out as? What's half of 27?
13.
Now they don't have the other mid-segment drawn, but I'm going to draw it in here just to close off and have all my triangles. So I connected PR. You can do that in a color if you need to see that that was added by us. Okay, and how many tick marks should it have on it? 2. It's going to be the same as these up here. Good. You want to color code your tick marks, you can color code your tick marks. All right, so I think we can answer all of the questions about length. So RJ, we already established that was 19. GJ, that's going to be that total length. What will that be? And RQ, this blue mid-segment here, we established was 13.5. Okay, so that's all of the length questions that they asked. Now they ask about some angles. So I'm going to use that strategy that I talked about where the tick marks help you. So the angle that we know here is 55 is this one right here. Okay, so if this is my 55-degree angle, it is between what 2 tick marked sides? The 1, this blue has a 1.
Oh.
And green is 3. So it's between the blue and the green, or the 1 and the 3, however you want to think of it. So that means every angle that's between a 1 and a 3, or a blue and a green, if you color coded, is going to be congruent to that. So that's going to be this angle, this angle, this angle. Y'all agree? Do y'all understand how I found that? Okay, so then the question down here that asks about the measure of angle HGJ, that's right here, HGJ, it's 55. Okay, and the one that asks about PQR, P to Q to R, that's this one in here. is also 55. If you need to color code to distinguish between those, I'll add a little yellow here. And a little blue here. All right. How do we feel about mid segments? Okay. All right. Your practice is in Delta Math. You'll get to it through, I don't know why this is on. You'll get to it through Canvas. Here's today. So you can click on it from the calendar right here. It should be on your to-do list. You can go to the module and get it. You can go to your assignment list and get it. Okay, but that'll take you to the Delta Math assignment. And I do want to remind you, when you have your Delta Math assignments and they look like this, the question types on the left, remember, if they have like question 1, question 2, etc., these were custom questions I put in. These came from like a worksheet assignment, and I don't want to give you the worksheet, so I just put them into Delta Math. Okay, so I have these set to 3 attempts, meaning it'll tell you, no, that's wrong, try again, no, that's wrong, try again, and then the 3rd time, it just marks it wrong. Normally, if it was a Delta Math Bank question, it would generate a new problem for you to try and get those points, right? But you don't get that with the custom questions. Okay, so just be careful on 1 through 6 here that say questions 1 through 6, because once you get that 3rd attempt wrong, it's staying wrong. You don't get a new problem to try and get those points back. So you can't get 100 anymore if you get those wrong. Okay, and then these up here, these are from the Delta Math Word Bank. I know they all have the same title, but I have a different type checked in each of them, so they're slightly different. But if you get those wrong, it will generate new problems for you to try. So you get unlimited attempts or unlimited problems on those 3. Good? All right, so again, on our calendar here, we've got the 4.5. If you have not finished the 4.4 from yesterday or the 4.3 from last week, you can still do those. And the 4.2, actually. I think today is the last day to turn in the 4.2 late. It should have been yesterday, but I extended it due to the Canvas not working on Monday. So if you still haven't finished 4.2, you might want to double check that 4.2 and 4.3 are done and get those done first. And then you can make sure the 4.4s are done. Remember, the Canvas piece was just identifying the type of segment, and then the Delta Math was the actually solving and calculating stuff. Okay, and then here's today's. Okay, our test is a week from tomorrow. We're gonna have a quiz on Monday. You can see the calendar here. That was it for notes. That was our last topic. We're gonna do some activity mini project type thing over the next couple days. Remember, Friday's homecoming carnival, so we're going to have shortened classes for the most part. I think your 7th period is long, but all your other classes I think are short. And then the quiz, and then a couple of review days, and then your test. Any questions? All right. Y'all can use your notes. You can work together. You can ask me questions.